Now that we've installed the operating system for the Elastic virtual machine, let's go ahead and install Elasticsearch. So like before, if you're not already remotely connected, connect to the Elasticsearch VM that is running. As before, we will tunnel over port 2222 using the user ID of Packt pub or whatever user ID you defined. And remember, we're tunneling this through our own machine, so we're using our localhost IP address, our loopback IP address, 127.0.0.1. Now that we're logged in, first we need to create the Elastic repository. Easily you would be able to copy and paste this, but in the event that you're not able to, we'll go ahead and do this manually. So using the program Nano that we installed in the previous step, we'll modify and create a repository file for Elastic. And we'll do a quick double check to make sure that we didn't have any typos. Everything looks good. And we'll use DNF or yum to install Elasticsearch. But first we want to validate the signing key so that we can ensure that we're getting a good copy of Elasticsearch. And we can do that using the RPM program. Now we can install Elasticsearch using DNF or yum. Once Elasticsearch has installed, let's set it to start on boot using systemd. And finally, let's go ahead and start it now. Just like before, we can check to make sure that this is running properly using curl. Previously, we used this running on our own machines, but it works the exact same way when it's installed as a package. And again, we haven't configured any security yet, so we can just use curl and localhost against this same machine over the default port of 9200, and we'll see that it returns back that Elasticsearch is now running. Next, let's go ahead and set up security for Elasticsearch. do a quick check against what's in the book compared to what we have here. And we'll restart Elasticsearch. If we didn't have something right in the configuration file, we would get an error that it wasn't able to start properly. Next, let's go ahead and set up our authentication credentials using the built-in binary Elasticsearch setup passwords. We're going to use the Elasticsearch setup passwords binary with the command interactive so that we can set the password. I'm going to set the password exactly the same for all of the accounts. This just makes it easier as we're doing demonstrations in labs. In an actual environment, you would want to use strong authentication credentials that you have at your organization. If you didn't use the interactive switch, it would automatically assign passwords for you, and then you would be displayed at the end, and you would be able to use that for authentication. Next, let's go ahead and check to make sure that the authentication is working properly. Using curl and port 9200, we'll notice that we'll pass it the pretty output. We'll notice that we get a 401. 401 meaning that there is missing authentication credentials, so we need to log in. So let's pass it the username switch with Elastic, and my password that I set for everything is password. If you don't put colon password or whatever your passphrase is, it will prompt you to do that. And we see that authentication is now set up, where I authenticated with the user ID of Elastic and the password of password, and now Elasticsearch returns back a result with security, whereas before, after we enabled security, we have a 401 HTTP error, meaning that there is an authentication failure. Next, we're going to install the Elastic Agent. This is going to be used for Fleet and is going to be the tool that will manage all the policies that go down to the other systems that are using the Elastic Agent for security or other collection. We're not going to configure it right now, but we're going to install it so that it's prepared for us further on when we're ready to configure it. So again, using DNF or Yum, we're going to install the Elastic Agent. We're going to configure it to start on boot, but not start it right now. Next, we're going to install Kibana, which is the web UI that we'll use to interact with the data inside of Elasticsearch. So just like before, we'll use DNF to install Kibana. Now that we've installed Kibana, we'll set it to start on boot using systemd. If you'll remember, we set up security for Elasticsearch, so we need to connect Kibana securely to Elasticsearch, and we'll use a key store in order to do that. Java key stores are a way to manage credentials, and that's what we'll use in order to connect securely to Elasticsearch. The username that we will use is Kibana_system. It will be asterisked out, but that is the username that you will use. Next, we'll use the same program, Kibana keystore, to add an Elasticsearch password. This will be the password that you set up when doing the interactive password setup in the previous step. Next, we'll modify the YAML file for Kibana to set it up for secure connection into Elasticsearch. Just like before, when we were doing a test in the previous chapter, we need to set the server host to 0.0.0.0 to allow anyone to connect to it. And we need to add the following. This needs to be any XPack encrypted saved objects encryption key needs to be any 32 character combination. Because we're not using this in production and we want to disable TLS so that Fleet can work properly without having to manage SSL and TLS certificates, we're going to add a disabled flag here. Next, we'll restart Kibana. And we need to make some firewall changes in order to allow all of these services to connect into the VM. We made the port forwarding in VirtualBox, but we need to actually use the operating system to allow those ports as well. We'll use firewall-cmd, which manages firewall D for us. We're adding port 5601, which is the default port to access Kibana. We're adding port 9200, which is the default port to access Elasticsearch. And we're adding the port 8220, which is the default port to access the Elastic Agent for Fleet. Next, we need to reload the firewall to apply the new configuration. And if everything worked properly, we should be able to browse to our local host on port 5601 and access Kibana. We'll log in with Elasticsearch with the Elastic username and password that we set when we were configuring the security for Elasticsearch. And we can see that we are now able to access Elasticsearch using Kibana. Now that we've installed Kibana and configured it to connect to Elasticsearch, let's enable the detection engine and load all the pre-configured detection rules. We'll discuss more about what the detection engine is and how to use it, but this is just part of the setup process. Clicking on the little hamburger menu and then going down to security and going to the detections menu. Click on Manage Detection Rules, and we're prompted to load the Elastic pre-built rules and timeline templates. Go ahead and click that. And after a few moments, you'll see that you've loaded for version 7.13.2, 535 detection rules have been run. Next, we're going to configure Fleet. Fleet is the central management platform that is used to control the Elastic Agent. Fleet and Elastic Agent as of June 29th, 2021 are still in beta, and some of these steps that we're going through in the book and the videos could be changed as the platforms move into general availability. I encourage you to stay updated with the Elastic documentation officially on Elastic's website on how to configure Fleet and Elastic Agent as those continue to adapt. So, logged into Kibana, we'll go ahead and log in. And click on the hamburger menu and then go down to Fleet. First time this loads for you, this will take a second as it builds all the back-end things. But after this, it's very, very snappy. First thing that we're going to do once this loads is we are going to click on Fleet Settings. By default, the Fleet server host is over HTTPS and using a default port of 8220. We're going to use the IP address of our internal network adapter. And if we need to know what that is again, just to validate, we can use IPA once we're logged into the Elastic virtual machine over Secure Shell or through the console. And I can see that my IP address is 172.16.105. Of note, if you don't use HTTPS here, this will still work, enrolling an Elastic Agent in Fleet. However, as you move forward to try to enroll the Windows virtual machine, the victim box, into Fleet, you will get errors. So this is someplace that you can go and simply make a change, and it will, the configuration will pick up, but you should set it correctly from the start if you can, obviously. Elasticsearch will be over HTTP, the default port of 9200. And again, our internal network IP address. Okay, once we validate that that is correct, click Save and Apply Settings. It's going to notify us of what we're changing. We're changing localhost 9200 for Elasticsearch to our internal network IP address. And then also the Fleet server had nothing, and we'll populate that with over HTTPS again, and our internal IP address over port 8220. Apply settings. Next, we are going to add an agent. And the first thing that we're going to be doing with our agent for the very first time is we are going to be giving a subtask to the Elastic agent that is running on the Elastic box so that it can act as a fleet server. So we don't need to download it because we've already installed it. And you can see that it is installed, however it's not running, which is perfectly fine. So we don't need to download it. Generate a service token. And then to start the fleet server, the platform is it's going to ask us what to do. It is running on Linux, however, we installed it with a RPM using the Elastic repository. So we need to change that to RPM, not running as Linux as a binary. We can simply use this copy command and paste it over here on on the Elastic system. And at the very end, it will say successfully enrolled the Elastic agent. We can click continue here. And we can wait on the agents page for a minute or two while it goes through its initial check-ins processes. I have noticed that if we check it's still not running, so we need to let's start the Elastic agent. And if we give it a few minutes, the fleet server should connect. As we can see, the elastic-packet pub.local has connected successfully, and we now have a healthy fleet server that we will use going forward. Next, we're going to build a Windows virtual machine. This is where we'll be launching all of our attacks into and collecting data into Elasticsearch. So inside of a browser on your host, go to Microsoft's website to download a Windows 10 evaluation. Microsoft.com en-us/eval-center/evaluate-windows-10-enterprise, and you can select ISO-enterprise, click continue, enter your administrative information, click continue, and you should be prompted with an option to download an ISO. Over in VirtualBox, we're going to create a new virtual machine that will be the Windows system. So clicking on new, and we can call it whatever we want. It will be a Windows 10 64-bit system. I would recommend 4192 as your minimum memory, 4 gigs of RAM. If you can give it more, it will definitely make everything smoother and faster, but if you're limited on resources, I would recommend a minimum of 4192. Clicking through the defaults, they recommend 50 gigabytes. You do that if you can, but if you're limited on resources, 30 should be fine. If you have to go lower, you probably can, but you're definitely going to run out of, you're going to be running low on space, which could cause some unforeseen complications. 30 gigabytes at a minimum. Create. Next, we're going to click on settings, and we are going to change the network adapter from NAT to internal network. And again, this is the inter-virtual machine communication, how you will connect to Elasticsearch. Clicking on system, we want to uncheck floppy and set the hard disk as the first boot option. And finally on storage, we want to click on the empty CD, select the CD that the ISO we downloaded in the previous step, and to the CD tray. And then we can start the virtual machine. This process will take some time. There will be several reboots. So it is building the operating system for us, and we will just watch while that does that. First, we're going to select some defaults here about our language. Install. It's going to ask us for our product key. We don't have a product key, so we can say I don't have a product key down at the bottom. You can select any of these that you want for the version that you downloaded. Windows 10 Home works perfectly fine. Accept all the licensing terms. We're going to select custom install Windows only and select the hard drive that we have, which is the only one we should. And then we'll go through the process of configuring and starting the installation process. First is several reboots while Windows configures and builds the operating system. Okay, Cortana is a virtual assistant that will help you throughout Windows. We don't need her, so we can simply hit the disable voice control button, and in a few seconds it will ask us, it will give you an option to proceed. First, let's select our region. Should by default give you the right one. Keyboard layout. Next, it's going to attempt to connect to the internet so you can log in with your Microsoft account. We're trying to avoid that because we don't want our machine that we're detonating malware to be connected to us in any way. So we didn't have access to the internet because we only allowed one network interface. So we can say skip for now in the lower left-hand corner here. It's going to ask us one more time, are we sure we want to skip? I mean, are we sure we don't want to set up the network? And when the answer is no. Next, it's going to ask us who's going to use this computer. I'll name it Packet Pub. And again, using my password for labs of password. Feel free to use whatever you want. Security questions, same thing. Lab machine, not concerned with being able to get back into this. I do not want Cortana to be my personal assistant. I do not want to share with devices. And all this targeted advertising, I'm going to set to no. I found that it makes for very noisy when you're doing data collection, that everything you do is trying to communicate and find information out about you. So turning on all the privacy features. Okay, finally Windows has finished the installation process. We're going to do some other configurations, but before we do that, let's install the guest additions so that it can make it a little easier and we can scale the box out a little better. So unlike when installing this for Linux, we don't need to eject the other one, the other ISO. We can simply, up in the devices menu, insert guest additions CD. Back in Windows, we can select the File Explorer and then this PC, and we can see the CD drive virtual guest additions. From here, we see VBox Windows Editions, then right click, Run as Administrator, select Yes, and then select and accept all the defaults. I want to reboot manually. Close this. Let's manually reboot the machine. Correction, let's shut down because we want to do some configuration that requires the machine to be shut down. Once the victim machine has been powered off, click on Settings. Click on Advanced. Shared clipboard. Set this to host to guest. This will allow us to copy and paste data into the virtual machine, but not the other direction. Additionally, go to Network, click on Adapter 3, enable Network Adapter, and set to NAT. Adapter 2 should not be enabled. Adapter 1, enabled, should be on an internal network. Adapter 3 should be on NAT. Click OK. Click Start. Now that we have the guest additions, we can change the view a little bit into scaled mode. Which will allow us to do things like this to make the virtual machine way easier to be read. Once the virtual machine stands up, you can click at the bottom and drag up, and it will prompt you to log in. First, let's do a connection test to make sure that we can access the Elasticsearch system through the internal network. Over in the terminal, I have secure shelled into the Elasticsearch virtual machine. We want to check to see if Elasticsearch is running. Running system control status Elasticsearch, I can see that it is active and running. I also want to check to see if I can connect to it locally to validate that I can curl interact with the Elasticsearch API. Using curl, remember piping it to or using the -u for user switch. And we can either do it this way, where we pass the password right here in the clear, or we can remove that off so that it prompts us. I'm just going to go ahead and put it here because this is all part of it. Lab, we don't need to be secret about what the username and password is for all this default stuff. Localhost port 9200. And we can see this return back that we have access. We want to check what our IP address is. It shouldn't have changed, and it hasn't. 172.16.0.105. This is our internal network IP address. Over on the Windows virtual machine, we want to fire up command cmd.exe, and let's see if we can use curl to connect to Elasticsearch, the Elasticsearch VM through the internal network. So using the same command. Well, this time we'll do it without the password so you can see how that looks. But instead of localhost, we're going to do 172.16.0.105 over port 9200. and it prompts us for the password. And as we can see, we can access from Windows directly into Elasticsearch. The last thing that we want to do is we want to enable PowerShell script block logging. And this it will be useful further on down when we do additional configuration on collection. So because we enabled the copy and paste function, we can open a PowerShell command or a PowerShell window directly from Windows and paste data directly in instead of having to type it manually. You can right click. We want to run as administrator. Yes. And we can simply paste information that you can pull from the book or from the internet on how to enable script block logging. And now we've enabled script block logging on the Windows virtual machine. This machine is ready for additional configuration for the different beats that we'll be collecting with, and then also the Elastic Agent. I would recommend, though not required, to connect to the internet and run all of the Windows updates and to install the new Microsoft Edge browser. It will make it easier to download the beats as we move forward. However, it's not required. I just recommend running all the updates because it'll just make it easier as we go forward having an updated system. Next, we're going to install the Filebeat beat onto the Elastic virtual machine, and we're going to enable the threat intel module. This module reaches out to a variety of open source feeds and collects threat indicators from them and pumps them directly into Elasticsearch. And we can use this later. So again, doing the exact same way that we installed the other Elastic services, we can use DNF to install it via the Elastic repository. So SSH secure shelled into the Elastic virtual machine. We will run DNF to install Filebeat. Next, we will enable the Threat Intel Filebeat module. Permission denied, so we need to run it with sudo, which are super user permissions. Listing all of the Filebeat modules with sudo Filebeat modules list. We can see these are all the different modules, and we have enabled the Threat Intel one. Before we can actually collect any information, we need to configure the different feeds. So we'll use nano. The files are stored in etc. into the threatintel.yaml file. Going down, we can see that the abuse URL is enabled and is set to true. Abuse malware is true. Malware bazaar is enabled and true. MISP is set to true. However, we don't have a MISP server. MISP is a malware information sharing platform, and we don't have that, and we don't need it for this lab. So we're going to set this to false. Additionally, OTX is Alien Vault's Open Threat Exchange. It is a fantastic resource. However, requires an API key that is free. Go to collect it yourself. However, we don't need it for this lab. And Anomaly, which is a threat intel provider, has a free feed called Limo, which we will be subscribing to, that uses guest as a username and guest as the password.
Now that we've modified all of this using Nano, again, you can use VI or anything else that you want to use for text editing. Just found that Nano is a little easier. Control X to exit, save, yes, and enter. Finally, we're going to run the setup to validate that we can access, we're going to test the configuration first to validate that we can access Elasticsearch and Kibana, and then we're going to actually push all the configuration into Elasticsearch through the ingest pipelines and the different dashboards with Filebeat. So first we will run Filebeat test config. The configuration is okay. We need to configure Filebeat to authenticate to Elasticsearch. We got this error when we try to connect to it. So we need to go into the back into the Filebeat configuration to do that. And that is in etc Filebeat, filebeat.yaml. This is the configuration file for all of Filebeat. By default, you don't need to configure this at all. However, we set up security, so we need to go down to the Elasticsearch section and set our credentials to authenticate to Elasticsearch. If you'll remember, we're using localhost 9200, so we're running Elasticsearch on the same system. However, we have a username and a password that we need to use. The username by default is Elastic, and the password that we set up is password. Again, exiting. Let's test again to see if we can now connect to Elasticsearch. Everything worked out good, we can connect. It gives us a warning saying that it can't connect over TLS, but that is expected. So now we will run Filebeat, the setup, and it will push dashboards and indexes and index patterns into Kibana and set up ingest pipelines as well so that the data can go in there. This will take a second. Okay, everything looks like it was loaded properly. Next, we're going to enable the Filebeat module, the Filebeat service to start on boot. And finally, we're going to start. The Filebeat service is now running and should be sending data into Elasticsearch. Let's check to make sure that it's continuing to run properly. We see that it is active and it is running. So let's log into Kibana. And we can see down in the stack management that the Filebeat index has been created and is sending data into it. The ingest node pipelines for the threat intel, anomaly, abuse URL, malware bazaar, and abuse malware have all been created. And the index patterns for Filebeat have been created. So we should see some data in the Filebeat index pattern from the threat intel information that we're ingesting. We do. Already we have 1,250 events. That is data that is coming in from the threat intel Filebeat module. We go to dashboards, and we'll explore all this later. We can search on the tags of threat intel, and there are a large amount of threat intel dashboards. But we just want to look at the threat intel overview. Again, we didn't enable all of the feeds, so they're not all populated. However, we do see that the 3 data sets that we enabled are populated and are sending data in, and we can explore this as we go forward.